TypeScript for JavaScript programmers. TypeScript stands in an unusual relationship to JavaScript. TypeScript offers all of JavaScript's features, and an additional layer on top of these, TypeScript's type system. For example, JavaScript provides language primitives like string and number, but it doesn't check that you've consistently assigned these. TypeScript does. This means that your existing working JavaScript code is also TypeScript code. The main benefit of TypeScript is that it can highlight unexpected behavior in your code, lowering the chance of bugs. This tutorial provides a brief overview of TypeScript, focusing on its type system. Types by inference. TypeScript knows the JavaScript language and will generate types for you in many cases. For example, in creating a variable and assigning it to a particular value, TypeScript will use the value as its type. Let hello world equals hello world. Let hello world string. By understanding how JavaScript works, TypeScript can build a type system that accepts JavaScript code but has types. This offers a type system without needing to add extra characters to make types explicit in your code. That's how TypeScript knows that hello world is a string in the above example. You may have written JavaScript in Visual Studio Code and had editor auto-completion. Visual Studio Code uses TypeScript under the hood to make it easier to work with JavaScript. Defining types, you can use a wide variety of design patterns in JavaScript. However, some design patterns make it difficult for types to be inferred automatically, for example, patterns that use dynamic programming. To cover these cases, TypeScript supports an extension of the JavaScript language, which offers places for you to tell TypeScript what the types should be. For example, to create an object with an inferred type which includes name, string and ID, number, you can write const user equals name, Hayes, ID 0. You can explicitly describe this object's shape using an interface declaration. Interface user, name, string, ID, number. You can then declare that a JavaScript object conforms to the shape of your new interface by using syntax like type name after a variable declaration, const user, user equals, name, Hayes, ID 0. If you provide an object that doesn't match the interface you have provided, TypeScript will warn you, interface user, name, string, ID, number, const user, user equals, username, Hayes, type, username, string, ID, number, is not assignable to type user. Since JavaScript supports classes and object-oriented programming, so does TypeScript. You can use an interface declaration with classes, interface user, name, string, ID, number, class user count, name, string, ID, number, constructor, name, string, ID, number, this.name equals name, this.id equals ID, const user, user equals new user account, Murphy, 1. You can use interfaces to annotate parameters and return values to functions. Function getAdmin user, user, // function delete user, user, // There is already a small set of primitive types available in JavaScript: Boolean, big int, null, number, string, symbol, and undefined, which you can use in an interface. TypeScript extends this list with a few more, such as any, allow anything, unknown, ensure someone using this. Type declares what the type is, never, it's not possible that this type could happen, and void, a function which returns undefined or has no return value. You'll see that there are two syntaxes for building types, interfaces and types. You should prefer interface. Use type when you need specific features. Composing types with TypeScript, you can create complex types by combining simple ones. There are two popular ways to do so, with unions and with generics. Unions. With a union, you can declare that a type could be one of many types. For example, you can describe a Boolean type as being either true or false. Type myBool equals true, false. Note, if you hover over my bool above, you'll see that it is classed as Boolean. That's a property of the structural type system. More on this below. A popular use case for union types is to describe the set of string or number literals that a value is allowed to be. Type window states equals open, closed, minimized. Type lock states equals locked, unlocked. Type positive odd numbers under 10 equals 1, 3, 5, 7, 9. Unions provide a way to handle different types too. For example, you may have a function that takes an array or a string, function getLength, obj, string, return object length. To learn the type of a variable, use typeof. For example, you can make a function return different values depending on whether it is passed a string or an array. Generics. Generics provide variables to types. A common example is an array. An array without generics could contain anything. An array with generics can describe the values that the array contains. This line is a shortcut to tell TypeScript there is a constant called backpack. And to not worry about where it came from. Since the backpack variable is a string, you can't pass a number to the add function. Argument of type number is not assignable to parameter of type string. Structural type system. One of TypeScript's core principles is that type checking focuses on the shape that values have. This is sometimes called duck typing or structural typing. In a structural type system, if two objects have the same shape, they are considered to be of the same type. Interface point. The point variable is never declared to be a point type. However, TypeScript compares the shape of point to the shape of point in the type check. They have the same shape, so the code passes. The shape matching only requires a subset of the object's fields to match. There is no difference between how classes and objects conform to shapes. If the object or class has all the required properties, TypeScript will say they match, regardless of the implementation details.